Hello, everyone. I'm Blake from Foley Systems, and welcome back to our Cisco Routing Essentials Configuration series. Today, we're diving deep into VLANs and subinterfaces. This is These are crucial concepts for modern network designs, and mastering them will help you build scalable, efficient, and secure networks. Let's jump right in. Let's start with VLANs, or virtual local area networks. This allows us to create logical network segments within a single physical network. Think of VLANs as virtual walls within your network that separate traffic logically. Even though it flows over the same cable and switches, it's going to separate them individually by seeing the VLAN tag ID within the packet that's being sent into the switch. The switch will determine which segment to send it on and what network, and so forth and so on. We're not going to dive deeply into VLANs. This is just going to be a brief overview. But what is a VLAN? A VLAN is a logical group of devices that act as if they're on the same physical network. Why would we use VLANs? They reduce broadcast traffic, improve security by isolating sensitive data, and managing devices simpler. What is an example of a VLAN? So here on my network diagram, we have VLAN 35 for users, VLAN 50 for our staff, VLAN 99 for management interface. Now, with each VLAN you create, you'll have to create a IP subnet for that VLAN. So let's just use 192.168.0.0. That's going to be our primary network. But now we're going to segment this off into each VLAN. So let's say VLAN 35. Let's go with 192.168.35.0 using the /24 notation. Now you could use any notation you like or any private IP address range, but for this instance, we're just going to use class C. And then so forth, so on. We'll go 192.168.50.0 for VLAN 50. And then we got VLAN 99, which is just going to be 192.168.99.0/24. Put that /24 into 50 before I forget. So therefore, we have now made our VLANs. Of course, you always want to plan out your VLANs and the purposes for them. That way, when it comes time to configuration, it's a lot more straightforward and easier to do. So what are we going to define as users? Well, our users are going to be, let's say you're running a business, or for a home lab environment, we are having guests over, friends, family. Then we'll use VLAN 35 for our guest and family. You could call it guest, you call it guest/family, or just users for a lot more simplicity. Next, we have VLAN 50. Well, you might have staff, you might run a little local business. But for this instance, we're going to change staff to IoT, which is Internet of Things. This is more popular in home lab environments and is starting to grow in enterprises. So it's a big thing to go over. You always want to segment your IoT devices. IoT always communicates to their region servers, so where they originate from. So you could buy something off eBay, Amazon, AliExpress, Alibaba, any of those companies. You might buy something that's not as familiar to everyone else as the big brands like Cisco, TP-Link, etc. So for that, we're going to create a separate IoT VLAN for them, so that way the traffic is separated for our main VLAN. So let's create another VLAN. We're going to create VLAN 10. Which VLAN 10 is going to be what we're going to call anything you would like. For this instance, I'm just going to call it my secure network. That way I know this is where basically all my servers and all my services are going to flow through. Then we're going to use 192.168.10.0 with the /24 notation. So that way we created a new VLAN. I'm forgetting VLAN tag right there. But you could create within a certain range. You could go from 1 to 4095 for VLAN, so you could choose between those. I do not recommend 1. VLAN 1 is the default VLAN. I would try to hit between 10 and above. That way it's a little bit different. So that way if somebody compromises your network, it's a little bit unfamiliar to them. It says, oh, it's VLAN 1. They get in a lot more easier. Important notes about VLANs. VLANs alone separate traffic. To enable communication between VLANs, we need an inter VLAN routing, which is where sub interfaces come into play. So we're going to switch over to our terminal emulator of choice, which I'm using mobile Xterm. And then you'll access your COM port, or if you have SSH enabled, like we did in the last video, you should be able to SSH within your client. So we're going to clear the terminal. So we need to access the CLI in enter configuration mode. Enable conf T. So now we're in a global configuration. Now, in our network diagram, I'll go reference it. As we can see that gigabit 001 is going to be for our LAN, while gigabit 000 is going to be used for WAN. So we're going to make sure interface 001 is enabled. So we're going to go interface GI for gigabit 0/0/1 enter. We're going to say the no shutdown command. That way we know the interface is up, and then we're going to exit. So now let's configure sub-interfaces. Sub-interfaces are actually the most easiest to set up on Cisco. They make it very straightforward and streamlined. So when we go to say interface, the interface you're going to use for your local area network or multiple, we're going to put a dot at the end of it, and then you're going to say for which VLAN. Well, let's configure VLAN 10. So now that's going to give you config subif. This tells us now we're configuring sub interfaces for the main interface. So we're going to make sure we turn on encapsulation. Of course, if you need to know which codec we're going to use, which is going to be the .10, 1Q. And now we're going to identify our VLAN. So what encapsulation .1Q basically is setting in this parameter is which VLAN are you going to be set to communicate traffic. What VLAN group do you belong to? For this instance, it's going to belong to VLAN 10. And my mistake from earlier on the VLAN range, it's 1 through 4094. Just want to make sure we get that clarified so that way don't throw confusion. Now back to configuration. So after we do encapsulation .1Q, your VLAN number, now we're going to set the IP range, or we're going to set the gateway for this VLAN. So all we're doing is giving this subinterface VLAN 10 an IP address for your IoT, your network devices to go to. So we say IP address 192.1. Oh, little typo there. IP address 192.168.10.1. with a default subnet mask of /24 or 255.255.255.0. We'll set that IP address to the interface, type in exit. Now we go on to the next subinterface, which is going to be VLAN 35. Make sure that is correct. Yes, VLAN 35. Click and enter, and then we're going to do the same thing as we've done before. Encapsulation. .1Q, the VLAN number, and then the IP address you want to give this interface to be the gateway to your VLANs, which mine is 192.168.35.1 with a default subnet mask of the /24 notation. And now we can exit. Next, let's do our next subinterface. And then our last subinterface for my configuration. You can set as many subinterfaces as you would like, but I'm just setting 4 for this example. And once you have set all your subinterfaces, you're going to type in end, and then you're going to do is write to memory. So basically, it's saving your running config to your start config. So what we done here is set up 4 subinterfaces, each associated with a VLAN. The encapsulation.1Q command is a key. As I was saying before, it tells the router which VLAN each subinterface handles. Each subinterface has its own IP address, which acts as a default gateway for devices in that VLAN. So to always verify that we set the subinterface, always run the show IP interface brief command. So this is going to tell us, hey, did we set our subinterfaces? Are they assigned correctly? And as we could see, they are set. We have VLAN 10, VLAN 35, VLAN 50, and VLAN 99. So always ensure that the router's physical interface is connected to a trunk port on a switch that allows VLAN tag traffic. So let's say for a Cisco switch, it's very simple. So on a Cisco switch, which I don't have connected right now, you go back to configuration T. So we're going to go back to configure terminal. For each VLAN you create, you just say VLAN, what number you want that VLAN on. You press enter. You say name. We said secure. And then you could type exit. Or you could continue saying which VLANs. Let's go with 35. We said was for users. And now we have set all the names to our devices, or not devices, all the names for our VLANs. To verify that, we say show VLAN. We say brief. And therefore, we could confirm that those VLANs have been configured successfully. Now, let's switch over to access control lists. With VLAN and subinterfaces set up, it's important to secure your traffic between VLANs using access control lists, or ACLs for short. ACLs allow us to control what traffic is permitted or denied between network segments. So we're going to create an example. This is just going to be a standard ACL to block specific IPs. Let's say, let's go back to configuration terminal. Let me reset the display so that way you guys can see it. We're going to say access list. Make sure it's there. Yep. Access list 10, which we're creating it for our VLAN. So we say 10 for our current VLAN. We say deny. By default, Cisco allows all and any IP address. Let's say for this instance, we don't want 192.168.10.100. We find we don't want that to communicate with nothing. We want that just to be an isolated device for testing or for security reasons. So we say we deny that. Now to allow or permit, we say access list our interface or our VLAN 10. We say permit, and then we're going to say any, or you can say 192.168.10.1. Try to make sure I got this correct. And you can throw your wildcard bits in, so 192.168.10. Let's see. It's a little fuzzy on this. I believe it's 50, yes. So that defines the range we want to permit. If you want to permit all IP addresses, you would just say any, and that would permit everything. Now, to apply the access or ACL to our subinterface, we go to interface, so our gigabit 001 for my instance, and that VLAN you want to give the access control list to. So we say 10 for this instance. Once you're in the subinterface, you want to now apply the ACL. So we say IP access group 10, and that's incoming traffic. And you can always say out to outbound traffic, but this is just going to be our inbound packets, not our outbound. So in this example, we created a simple access control list to deny traffic from a particular IP address in VLAN 10, while allowing all other traffic. You can use similar logic to block or permit traffic between VLANs based on security requirements. Now, what we're going to do is we're going to create an advanced ACL. So this is going to be VLAN to VLAN traffic. So to do that, we're going to say IP access dash list. We're going to say extended because we're going to manually configure this, and you give it a name. So we're just going to call this VLAN traffic. You, of course, want to put more details saying which VLAN it's from. So we can say VLAN 10 to VLAN 50 for this example. So that gives us a name for it. Now we're going to say permit the protocol you want to permit, which is going to be TCP. It could be any protocol. You can use UDP, TCP, ICMP, but for this instance, we're just going to do basic TCP. Of course, always adjust it to your needs. Now we're going to say the IP address subnet, so 192.168.10.0, and then we're going to put a wildcard in there. Of course, you always want to put your source wall bit card. So This basically is telling it that these three numbers stay the same, but the last bit can always change to 1 through 254. And now you want to say our other VLAN, so it's 192.168.50.0 with the same wild bit card as we used for VLAN 10. Now, this is where you could put your matching. So this will basically match the packet, your fragments, anything you really need. But we're just going to say a packet at a particular port, just that way we control port traffic. So we use EQ. And then we're going to say port 80, HTTP. We press enter. Then we'd say deny IP any. Now this is going to basically deny any other IP addresses besides the one we have defined traffic. And we say exit. And now we go back to our interface. Gigabit 001, but this time you're going to set it to the VLAN you're trying to communicate to. Instead of the 10 dot, we're going to go to the 50. Then we're going to say IP access group, and then of course the name of our list, which should be VLAN 10 to VLAN 50. And then you say that's the incoming packets. Here we have created a extended access control list that allows HTTP traffic between VLAN 10 and 20 while blocking everything else. Extended access control lists gives you fine, how would I put it? We'll just say very refined control over traffic flow. You can control specific ports, protocols, and everything else between. So after we have configured our access control list, always type in exit or int. That way we get back to our executive privilege mode, and then you're going to type in WR or write memory. And to make sure our access control list operation was successful, we type in show access -list. And there we go. In this video, we covered VLANs, subinterfaces, and ACLs, key components of a robust, secure network configuration. Mastering these skills ensures that your network is not only functional, but also secure and efficient. In the next video, we'll explore static routing. Don't forget to like, subscribe, and comment with any questions or topics you would like me to cover. I'm Blake from Foley Systems. See you next time.